The next kind of loop we'll take a look at is called a for loop. Right? We'll see that for loops, just like while loops, will only execute the statements in the body of the loop whenever the loop condition is true, the test condition. It's also possible to write any while loop as a for loop and any for loop as a while loop. We typically use for loops when we know how many times we want something to execute. Right? In this cartoon, we can see this kid was cute because he knew for loops, and he was able to write a loop that would print out 500 times, "I will not throw paper airplanes in class." Right? So let's take a look at the syntax of this for loop. Right? Our new keyword, for, in the last loop we had a keyword while, here it's called for. So we're going to have for, followed by parentheses. Inside the parentheses, we can put three different C statements. The first one will be an initializer condition. So we could actually declare variables in here and initialize them. We could just simply initialize variables to a starting value. We'll see that these statements here only ever execute once. And after these finish executing, then this test condition executes. So we'll write our test conditions there that control how many times the loop executes. Then as long as this condition is true, we'll perform statements in the body of the loop, and then we'll come back and usually increment our loop counter. Right, let's take a look at the control flow of the flow chart. So the way this works is this statement here, this initializer, it comes in and executes this first. It happens once and only once. Then the next thing that's done is the test condition is checked. If this test condition is true, our code flows through here. We execute any statements in the body of the loop. So here it's called the code block. Then we come back and we perform the increment statement, and we loop back around and check the test condition. So as long as this is true, we keep performing this execute statements in the body of the loop, increment, loop back around. Whenever the condition's false, then we skip over the statements in the body of the loop and the incrementer, and we execute whatever statement follows the loop. Right? But once again, just like the while loop, the test condition is evaluated before executing any statements in the loop body. Let's look at example 5 here. Right? We had an example with a while loop where we printed out the numbers, I think 1 through 10 or 0 through 9. Here we're going to do it with a for loop. We're going to go ahead and set I equal to 0. As long as I is less than 10, we're going to execute this statement in the body of the loop. And we'll come back up and perform the increment and perform the test and loop back through. Let's actually run this in code blocks, see the behavior, and then talk more about how it works. Here's example 5. I've just got some extra comments in here explaining the order of execution. So here's our variable I. Let me put the cursor down here. Let's perform a run. Oh, sorry, I need to add this project to the active file. I hadn't done that yet. I need to remove my last file. All right. Let's build this. All right. So let me do a run to cursor so we can bring up our watch window. All right. And once again, if you're following along and your debugging watch window doesn't pop up, you can go to your debug menu. You can go to debugging windows. See how my watch window is checked? All right, check. Make sure yours is checked so it will pop up. All right. So here, the only statement we've executed is declaring I. I has some garbage in it. The yellow arrow indicates it's ready to run this statement. So as the comments indicate, this first statement, I, let's assign 0 to I, is executed first. The next thing that happens then, the value of I is checked to see if it's less than 10. So when I is 0, 0 will be less than 10. When this is true, we're going to execute the one statement in the body of the loop, which is this printf. Notice we're using curly brackets here to indicate statements in the body of the loop. Right? We can have compound statements, so many statements in here, or we can have one statement. So let me just hit next line. We can see that I has been set equal to 0. We're ready to execute this because the test was performed and was true. Right, so if I hit next line, what happens is we'd see the printf executed. We have I and 0 up here. Now, what we don't quite see with a debugger is the fact that what's going to happen next is it's going to perform this statement. Let's add 1 to I, store it back in I's memory, and then it will perform the test, and we'll see we're ready to execute this because the test will be true. So next line, you can see I is changed to 1. 1 is less than 10, so it falls into the body of the loop, right? It's ready to execute that statement. So I type next line, right? Bring this back up. We can see this printf executed. We now have I of 1. And once again, when this finishes at the end of the body of the loop, it comes back up here and executes this, the increment statement. Right? Adds 1 to I, then it will perform the test. When I is 2, it will be less than 10. That will be true. So next line, we can see I was 2, 2 is less than 10. It's ready to execute this statement. We can see if we just kind of keep hitting next line, right? We're going to come back up here, add 1 to I. You can see I became 3, 3 was less than 10. We'll fall in and we'll execute that statement. Oh, I hit the step into, right? That actually just takes me into how the printf function works. Let's step out so we can come back, right? And so we can see at this point, right, we've got 0, 1, and 3 printing out on the screen. Right? If we were to just keep hitting next line, we could watch I increment. If wish I could keep both these windows up at the same time, we can see that our printf is executing. Of course, this will go on for a little while. Right? We're going to add 1 to I. We're going to check to make sure I is less than 10. We'll print that out. And if I wanted to speed this up, well, it's finished. It's our first time seeing this. So let's just watch I keep incrementing. Right? I is 9, 9's true, but now we add 1 to I becomes 10. That's no longer true. So we'd fall out of the body of the loop and be ready to execute the return statement. But we can see it generated our output there. Right. All right, let's end that. Right. So this is just very similar to a while statement. Right? In our other example, we had something like we initialized I to 0, and we could say while I is less than 10. We would want to then go ahead and print out I in the same way. And now we say I equals I plus 1. Right? And this would have the same behavior. As a matter of fact, if I comment this out here, and we run this program, so let's build and run. Right. We see that we get the same output behavior. Right. So you can use this as a comparison you can write it this way for the while loop. And most students, most people when they learn to program prefer the while loop because it's more clear here that this I is initialized to 0 only once, and then the test is performed, then the printf, and then the increment. Here we have to remember that these statements, we can have multiple statements here, but this statement is performed once, only once at the start of the loop. Then the test is performed. Right? When the test is true, comes in and performs the statements in the body of the loop. When it's done, then it comes up and performs this statement, and then it performs the test. When the test is true, it performs this statement. Right? Gets to the end of the loop, it loops back up, and then performs this statement, right? And as long as this is true, we'll just keep we'll go through this cycle here of perform test true, statements in the body of the loop, loop back up, perform the increment, right? And then perform the test, which is very similar to how the while statement does it. When this is true, right? Statement in the body of the loop, then we increment, then we come back and we do the test. So here's the equivalent while loop for this for loop. All right, let's look at another example. All right, so let's see what we think the program output might be here. Let's look at our program. We're going to print out, well, it looks like we're going to print out the value of 1, then we're going to print out the value of 2, and now we've got a loop where we're going to set I equal to 0. And the next thing that will happen is we'll check to see if 0 is less than 4. It will be true. So we'll go ahead and print out 3 and print out 4. And then we'll add 1 to I. So let's just see this in the debugger. Right. Just run our example. So our next example here, let me close so you can see when I was debugging, I popped open standard.io.age. Right, here's example 6. And let's go ahead and add that file to my project. Yes. All right, looks like some of my windows got smaller. Come back. Remove 5. Let's put this in. Let's do a build and run. Let's see the behavior and then look at why we had that behavior. Right, so we printed out the number 1. That came from this statement being executed. We printed out the number 2, result of this statement. We set I equal to 0. We tested with 0 less than 4. That was true, so we printed out 3 and 4. So there's that pair of 3 and 4. Right? Notice they're on the same line because there's no new line character here. Right. Next thing we do is we loop back up and we check the value of I. So this test is going to be true for when I equals 0, I equals 1, I equals 2, I equals 3. Right, so it's going to be true 4 different times. So look, we've got 1, 2, 3, 4 pairs that printed out. And then finally, when this is no longer true, we come down here and print out this statement. All right, now let's use the debugger. All right, so let's do a run to cursor. All right, and I can see that I has garbage value. I haven't printed anything out yet. Let's do a next line. All right, we pop that up. We see we have the number 1. We do a next line. We have the number 2. Right. Now we're ready to enter our loop. We're going to initialize I to 0. Next line. It initializes I to 0. It checks to see is 0 less than 4. That's true. When this is true, it's in here ready to execute this line. So we'll go ahead and print out 3. We'll print out 4 in the new line character right there. Now we come back up and it's going to perform this increment function here. Right? It's going to add 1 to I. So next line, we can see I was 1, so it added 1 to I, and then it performed this test. Was 1 less than 4? Yes, that was true. We come in here and we print out these pairs. We can see we got that second pair printed out. Right, next set of actions, add 1 to I, so I is going to become 2. Perform the test. Is 2 less than 4? Yes, it will be true, so we'll drop back in here. All right. All right, we can see I is 2. All right. And now we're going to perform this increment. I is going to become 3. We'll perform this test. As long as it's true, 3 will be less than 4. We'll do that. So we can see that's true. Now, we're going to add 1 to I. I will become 4. 4 will not be less than 4. We can see our control flow comes down here, and we'll go ahead and print out the value of 5. And I'm missing my return 0 from that code. That's not very good, is it? All right. All right, so you can see then a better idea of how the for loop works. You can learn a lot about code by running through the debugger and seeing the steps that it takes. All right. Really need to improve that example with my return 0 there. Right, so that's the end of that particular example. Let's take a look at our next topic here. All right, what happens if I remove the braces? Just like the while loop, if I don't use the curly brackets, right, those curly braces, then the one statement following the body of the loop, which is the printf 3, executes. This will execute as long as this test condition is true. When this test condition becomes false, it'll come down here and execute this statement. Remember, the indentation is just a style convention to make it easier for us to read. It doesn't mean in C that it will execute those statements within the body of the loop. Now let's take a look at that. All right, if we were to run this program, we would see we print out the 1, we print out the 2. I is going to be equal to 0. We're going to set I equal to 0. 0 will be less than 4. This is true, so we print out this first 3. We come up and perform the increment, so I becomes 1, 1's less than 4, we print, this is true, we print out the next value of 3. We come back up, increment I to 2, 2's less than 4, this is true, so we print out this 3. Come back up, add 1 to I is 3, 3's less than 4, we print out this 3. Come back up, increment I is 4, 4 is not less than 4, so we drop down, we print out the 4, then we get the new line character, and so then 5 is printed on a line all by itself. Right. So that's the effect of leaving out the curly braces. Right. If we leave those out, only one statement, the one statement following this is executed. So we need the curly braces to have multiple statements executed within the body of the loop. Right. The other thing being, we mentioned with while loops that we want to avoid putting a semicolon here. Right. If we were to put a semicolon at the end of this, remember a semicolon is the null statement. It is a C statement. Oh, in this case, what this would do is this would run through and it would count from I equals 0, right, all the way up until when I equals 3, this test would fail and it would come down and print out just the value of 3. Let's take a look at this example in action. All right, build and run. Okay, you can see our only output is I of 3. Right, so run the cursor. All right, I has garbage in it at this point. All right, next line. We're going to set I equal to 0. 0 is going to be less than 3. Actually, what it did is it ran through this whole thing without us being able to see it, which isn't really great with a debugger. But you can notice in your output, if you're running this, there's no output at all. It went through, it said I equal to 0, performed the test was true, it added 1 to I became 1, 1 was less than 3, so it said do nothing. As long as this test is true, do nothing. When I finally became 3, 3 was less than 3, it's going to come down and execute this statement, right, which we see we get that output on the screen and our program ends. So these are things that as a new programmer, right, you'll typically do. Experienced programmers accidentally do this once in a while too. So remember, the semicolon is a no op statement. The null statement, it will cause you problems if you type it in. So when you have unexpected behavior from a for loop, go back and look. Did I accidentally put a semicolon where I shouldn't have? Have I used curly brackets to include multiple statements? Things like that we have to get used to. And some of those errors are difficult to find, right, at first. If you get experience with them and make the errors, you'll know what to look for. Okay, but we can nest loops as well, right? We've learned to write while loops, we've learned to write for loops. We can put a loop inside of a loop. So if I now put a for loop inside of another for loop, let's take a look at how many times the code executes. Oh. So build and run. Build and run, I get a lot of output, and I'm wondering where it's coming from. Right, I can take a look at that. In terms of the program, we can step through the debugger. We can see that our first line says program start. Right, and then we're going to get some values for I, and then it's going to print out some values for I and J. Let's take a look line by line at how this happens. All right. So run to cursor. Right. So with run to cursor, it's executed these two. I and J have some sort of garbage in memory. It's printed out my message program start. Now it's going to come in here and initialize I to 0. It's going to assign I to 0. It's going to check, retrieve the value of I from memory. So is 0 less than 2? Yes, it is. That's true. So now it will come in and perform this statement. So let's just do a next line. Right? This was true. We're ready to execute this line. Notice here I is 0. We're going to print out the value of I. If we say next line, look at our output. We've printed out then the value of I, this statement. Well, now we've got another loop in here. In this loop, we're going to set j equal to 0. We're going to compare j to 3. 0 will be less than 3. Let's do that. Next line, you can see j is 0. We're now going to print out the value of I and j. So I0, J0. So we execute that print statement, I0, J0. Right. Now this is our one statement associated in the body of the loop. And so when our loop finished, it came back up here, right? It stays with its current loop. It comes back up here and it increments j, plus plus j. Right. Well, we will see when we hit next line, j will become 1. It will compare them 1 less than 3. This will be true, and we'll come down and execute this line of code again. So next line, notice j is 1. 1 was less than 3, so we're ready to execute this, where we're going to print out the value of I. Notice I is still 0, and now j is 1. Right. So if we do that, we can see our output. We have I of 0, j of 1. Right. Now we'll add 1 to j. J will become 2. We'll perform this test. 2 will be less than 3, and then we'll print out I and j again. Right. Execute that. Right. We can see we have I of 0, j of 2. Right. Now we're going to perform the increment. J will become 3. This will become false. We'll drop down to here. Next line. Notice I is still 0, j is 3. We're down here. We're going to print out the message that the j loop is finished, right? We've cycled through this loop for j equals 0, j equals 1, j equals 2. We executed this statement. And now next line, right, we can see, then we printed out the message that the j loop is done, I is 0. All right. Well, this statement j loop is done. The next thing that happens is this curly brace marks the end of this for loop. So this marks the start of the body of this for loop. This marks the end of the body of this for loop. But once we reach the end of that body of that for loop, we come back up here. We're going to increment I. We'll add 1 to I. I will become 1. 1 will be less than 2. That'll be true. And we're going to drop back down and perform all the statements in the body of the I loop again. Right? So next line, you can see that I is 1. 1's less than 2. Right, we pop this up. We've now printed out I of 1, this statement. And now we're going to go all the way back through the j loop. We're going to set j back to 0. 0 will be less than 3. We'll print out this statement in the body of the j loop. Next line. Right, you can see j is 0. That passed that test. Next line. We printed out I is 1, j is 0. Right, we move back up here, increment j. Right, add 1 to j. J will become 1. 1 will be less than 3. We'll drop back down and perform this again. Right, so j is 1. We perform this. Right, we have that output, I1, J1. Right, same thing. Now we're going to add 1 to j. We're going to compare j less than 3. So j is 2. 2 was less than 3. Notice we're in the body of the j loop. We pop back up. We're going to add 1 to j. J will become 3. 3 will not be less than 3. So now we flow down here to right outside the end of this loop. And now we say next line. So j loop done, I is 1. We're at the end of the body of the I loop, right? It controls this flow. We come back up here. We're going to add 1 to I. When I becomes 2, it will fail this test. So next line, I was 2, fails the test. It's now ready to execute this line, which would be program end. If we say next line, right? We'd see our output says program end. Right. So we can nest loops within loops. We can put a while loop within a for loop within a while loop. You can put any other coding structures in here, if statements, switch statements, things like that. All right, so now we can greatly change the way our program executes. We can have sections execute multiple times. So nested for loops, right, is a little bit more advanced from the normal loop. We'll learn later when we get to arrays, particularly 2D arrays, that we'll want to loop through 2 dimensions using nested loops. Okay. So for versus while. We prefer to use a for loop for a counter-based loop. we have an explicit counter variable, and it's easy to see how the counter is modified each step. Right? A while loop is preferred for sentinel-based loops. A sentinel-based loop is one that we don't know how many times the loop will execute. It's just going to continuously check for a sentinel. We've seen an example of that in the while loop lecture. And the other thing is, the important point is either kind of loop can be expressed as the other. So it's really a matter of style and readability for the way you prefer to write. Of course, if you're in a course and you're required to write one or the other to learn them both, you have to follow those instructions. All right. That's the end of for loops. The next lecture will be on do while.